In a previous video, we had gone over how to add an OH group to the less substituted side of a double bond, but in this video, we'll be going over the other way of adding an OH to the more substituted side of a double bond. So let's say we have this molecule over here, and then we have some Hg, some acetate here, OAc here, and we have these two electrons over here. So what happens first is that these electrons from this double bond actually attack the mercury, and this falls off. So we get this product, Hg-OAc. And remember, since that this carbon lost some electrons, it is now positive. And don't forget the OAc negative because it got kicked out from this step over here. Now I wrote here no formation of carbocation, but I technically lied to you because of a carbocation here. But what I mean by no formation of carbocation is, I mean no formation of a movable carbocation. Sometimes when you make these carbocations, what can happen is you can have hydride shifts or methyl shifts to make a more stable carbocation. But in this case, this happens so fast, this next reaction happens so fast that it does not have time to move if it could form a more stable carbocation. So what happens next is these electrons actually attack the carbocation here, and you get the next product, or the next intermediate. You get Hg-OAc. Now, what I should have done here, I should have made this a certain type of bond here, and I guess I'll do wedged, and I gotta fix that one part. I have to make this wedged, I mean dashed. Sorry, dashed here, and these two are dashed. So you have this triangle intermediate over here, and now throws a positive here. So there is no formation of a movable carbocation because as soon as you make this reaction happens. So this carbocation has no chance of moving if it can make a more stable carbocation. So now we're ended up with this intermediate here. And remember, we're in H2O. So what happens next is that the water actually attacks from the back side of this triangle intermediate step over here. So this water can actually attack. Now, which side does it attack? Well, it attacks the more substituted side. So what happens is it attacks here. And then what you get is you get this. Let me move this down over. You get structure that looks something like this. Hg-OAc. You get something like I should have done this. Gotta fix my arrows. So since this is dashed, this H2O incoming group has to be wedged because it has to attack from the back. So now we have this here, and remember there's a positive charge here now because oxygen is bonded to 3 different things. So how can we remove this positive charge over here? Well, remember we made acetate ion here, so what can simply happen is this acetate ion can simply depronate one of these. I have to remember to keep switching these colors to be consistent. This goes here, and these electrons go back to the oxygen over here. So now our next intermediate looks something like this. This is mercury, Hg-OAc, with an OH here. With an OH here. Let me draw that better. OH. So now we have finally added the OH group on the more substituted area of the double bond, which was here. So now it is here. Now the only thing left to do is to remove this Hg-OAc group. And to do that, all we gotta do is perform the second part of the reaction, which is simply NaBH4 with, I believe it was something like OH negative. And all this does is it just replaces this Hg-OAc group, this is an A, Hg-OAc with a hydrogen. And I won't get into the mechanism of this one, just like the one in the hydroboration oxidation step, because it's rather complicated. And all that's really happening is just the mercury is being replaced with a hydrogen.